I can do encoding on top of that. So for encoding, first I need to decide what all characters can be present in the URL, that is the short code that I'm generating, and on top of that how many characters would be sufficient. And due to this there would be a huge delay, right? So your redirect would take a lot of time. So now let's say there is a CDN which is present near to India, or maybe you can say it is present in Europe. So this one is near to as compared to US, because the requests are coming from India, and the Europe region would be nearer to. If you're planning to give an interview soon, this video is for you. I recently gave a mock interview and I found it really helpful. So when you give a mock interview, you get an interview like experience, because you have to explain everything like in interviews. You have to create the high level diagrams and you get feedback on that. It can be really helpful because you can learn from your mistakes and make sure that you don't repeat those mistakes in the interview. And by doing that, the probability of clearing the round and getting an offer increases a lot. So in this video, I'll discuss my experience of the mock interview of the question design a URL shortener or design TinyURL. In the beginning, I was provided with the functional requirements, and after this I was asked a few questions. So in this video what we'll do is like walk through the functional requirements first, through which we will understand what is the system that we want to design, and after that I will tell you what were the questions that were asked to me one by one, and I'll tell you what was my answer to it and what was the feedback that I received from the interviewer. My recommendation to you is that whenever I tell you the question, you can pause the video and write down your answer. Although your answer may vary from mine, because system design questions are very open-ended and there can be multiple approaches. But still, when I will tell you the feedback, you may compare it with your solution and you may learn from that part. Okay, so let's start with the functional requirements first. Okay, the first one is user should be able to submit a long URL and receive a shortened version. So as this is a URL shortener, of course you want to give a long URL, the complete URL to the system, and it should be able to return you a short URL for that. Number two, users can optionally provide a custom alias or expiration for the shortened URL. So this system also allows customization of the short URL. Number three, users should be able to access the original URL by using the shortened URL. So whenever you hit the short URL, it should redirect to the actual long URL. And we were also provided with the scale of the system. So we need to design our system so that it can handle high level of scale. Alright, these three were the functional requirements that were provided to me in the question. So after this, interviewer asked me a few questions. So let me take you through the questions one by one. So here is the first question that was asked to me by the interviewer. So as I have already told you the functional requirements, now that we have the understanding what we need to build, I was asked like what are the non-functional requirements of this system. Okay, now on screen I have displayed to you what was my answer. The first non-functional requirement that I mentioned was high availability, and with that I also gave a brief summary that the user should be able to create a tiny URL or open the long URL from the short URL anytime. So our system should be highly available. Number two, I mentioned low latency. So because last time I was provided the feedback in the mock interview that I should provide the numbers as well, hence this time I mentioned latency should be less than 200 milliseconds. So for both creation of the short URL or the redirection, this should be fast and it should happen within like 200 milliseconds. Number three, I mentioned reliable, which means when the system provides a short URL, it should always redirect to the same long URL. So it should be consistent in that way. And number 4 point I mentioned was unique. So there should not be any ambiguity. It means that each tiny URL should be unique to the long URL. You can say it is a one-to-one mapping. So these were the 4 non-functional requirements that I mentioned for this system. Now let's see what was the feedback that I received on my answer. First, let's talk about the good feedback that I received. I identify the key non-functional requirements like high availability, low latency, reliability, and uniqueness of the short URL. Another good thing about my current answer was that I made it specific for the current system, right? Say for example, we are talking about the TinyURL. So I gave all these things like uniqueness specific to that thing only. I did not give the answer in generic way. So this is good because we want answer to be specific to the current system. And another good thing in this was that I mentioned the numbers here. So for example, when I talked about the latency, I also mentioned it should be within 200 milliseconds. So this was a feedback that I received in my last mock interview, and I learned from it and improved on it this time. So this is the benefit of mock interviews. You can learn from it and perform well in the actual interviews. Now after these good things, a minor suggestion that I received was the system like TinyURL. I can also mention that availability is given more priority as compared to the latency, right? A few of the requests take more time, but it's more important that the system is available, that the requests are actually redirected. Although it took a few more milliseconds to do that, but we are prioritizing the availability over the latency part. So I could mention that in this high availability part. Okay, so this was the first question that was asked to me, which was the non-functional requirements, and I told you my answer and the feedback for this. Now let's move to the second question that was asked to me in this mock interview. The question was, what are the core entities of the system? So when we say entities, we mean in terms of database tables. So what are the major entities that are required in the system? Again, the recommendation is, like, before I present my answer to you, you should also think about it and write down your answer to this question. Okay, this is my answer that I gave for this question. So according to me, there are two major entities in the system. One is the URL info, which would contain information related to the URLs, which would have the long URL and then the short URL. Then it would also have things like the expiry. So all such things would be part of URL info entity. And the other one would be the users entity. So in case we want to make it sign in based, like for example, only after sign in you would be able to do that, and we want to keep the user specific information, for that I have created a users entity here. So this was my answer. Now let's see what was the feedback that I received on this answer. Okay, so in the feedback, first let's talk about the good things that I did in this answer. So I identified like URL related things, like URL info is the entity required which would contain the mapping for the long URL and the short URL. So that's a good part. And apart from that, I also kept in mind the future scope that we could make this system sign in based. So for that I mentioned entity user. So that's also good that I am able to see the future scope of the system as well. Now talking about the suggestion, one minor suggestion I got was like I could keep a better name for this entity. Instead of URL info, I could keep it URL mapping, because it would contain the mapping of the long URL to short URL. So URL mapping would be a better name for this entity. That was a minor suggestion that I received on this answer. So after this second question, let's move to the third question, which was related to APIs. So what all APIs would be required for this system? Now let me tell you what was my answer to this question. Alright, this was my answer. I mentioned couple of APIs in this. First one is get TinyURL. This is HTTPS based and it's a post API. I also mentioned the request body and the response this time because this was the feedback which I received in last mock interview. So I learned from it and improved this time. So the request body is something like this. You can see it contains the long URL. It also has something like customized alias because that was mentioned in the functional requirement, but it's optional. Apart from that, we also have the user ID. That's also optional. It would be required if we talk about the sign in case, which is not always required, so it's optional. And also I've mentioned the TTL, which is related to expiry of the URL. So this was a request body of this post request, and the response is that you will get the tiny URL. So basically you'll get the short URL which would be corresponding to the long URL. And the second API would be related to redirection. So I have mentioned redirect URL, the API name. It would be HTTPS type again, and it's a get API. So how to pass the short URL, I mentioned mentioned, I can pass that as a query param because it's a get API. So I can do something like short URL equal to. So this was my answer. Now let's see what was the feedback that I received on my answer. First, talking about the good feedback, I identified both of the cases, like where we have to get the TinyURL and redirection. So that was a good part. Apart from that, one more good thing is that I kept in mind of the optional things like the customized alias, user ID, expiry. So all those things I mentioned in the API request itself, so that's also good. Also the request and response are mentioned in my answer, so that is good part. Now one minor suggestion that I received on my answer was that instead of making short URL as a query param in the get API, I could use it as a path parameter. So this is an example for the same. So when I say the query parameter, I would use it something like this. Like I would put a question mark and then I would say short URL equal to, and then I'll provide my short URL. So this is the query parameter way which I suggested, but the feedback that I received was instead of making it as a query param, I should use it as a path param. So you can see this is an example of path parameter. So after my endpoints there is a slash and then there is the short URL directly. So generally query params are more used when we talk about the sorting, filtering, or for the optional parameters, but because this API, this is the most fundamental thing, the short URL, and it's not optional, so it makes more sense to use it as a path param rather than the query param. So this was a minor suggestion that I received. Another minor feedback that I received on my answer was related to the naming of these APIs. I made the naming more like verb based, rather it should be more like noun or resource based. So some improvement can be done on the naming side, but nothing major in it. It was a kind of a minor suggestion only. Now after this, let's move to the fourth question. So the fourth question was, how will we get the short URL? So the interviewer also mentioned that for now I don't need to worry about the algorithm for generating the new short URLs because that would be covered later. So for now I had to just draw the basic high level design of the components that would be required to generate the short URL and explain the same. So let me share what was the answer that I gave for this question. Okay, so this is the high level diagram that I gave as an answer. So in the beginning we have the client. I'm using the HTTPS protocol for my REST APIs, and then there is a load balancer. Why load balancer is required? Because this system is at huge scale, so we would require horizontal scaling, right? There would be multiple servers, and in order to handle the horizontal scaling, load balancer would be required. So after load balancer there is a gateway. What's the responsibility of gateway here? Gateway will be used for authentication. Say for example for the sign in users, it can be checked here. And then one important part of gateway is that it can be really helpful for the rate limiting. So for example, you are getting a lot of requests from a particular IP address, so we can apply rate limiting check for that, so that malicious calls can be blocked. Because a lot of times what happens is there are malicious calls, or you can say robocalls, like you're getting a bulk calls from single IP address which is trying to make our system down. So that can be handled by the gateway, and then gateway would be also helpful to redirecting the request to the correct microservice. Okay, so after gateway, let's talk about the microservice, because in this question we were asked just about the logic to create the short URL. So I have mentioned only one microservice here, which is URL generator service, using which I will create a short URL. Now alongside this microservice, I have mentioned the database, because we would need to store the information related to mapping of long URL versus the short URL. And with database, you can also see I have mentioned the entity and the important fields that are required. So this was the feedback that I received in one of the mock interviews. So I took that, and from now on I am including this alongside the database. So entity, I have mentioned URL. You can also say that URL mapping, because that was a feedback that I received in the last question only. The naming of the entity could be URL mapping, and these are the important fields that would be required. You can say long URL, short URL, expiry of the URL. Okay, so alongside database, one important thing is the Redis cache. So we can't serve all of the requests from the database because that would put a lot of load on the database, as well as if we fetch everything from the database, the response would be quite slow. We don't want that. So to handle that, we have the Redis cache. Redis cache is generally key value pairs, so we can keep the mapping of the short URL and the long URL there, and it can be really helpful. So this was my answer. Let's see now what was the feedback that I received on my high level diagram. Firstly, talking about the good things that I did in my design, that I mentioned the load balancer, gateway. So my design contains all the components which are responsible for some of their roles, and I've also mentioned there is a microservice architecture. So all those things are really good. Apart from that, another good thing is that I have kept both the things like database and the cache. Database will be used for the persistent storage. Redis would be used like in memory. It would be helpful as a cache where the responses would be quite fast and it would reduce the load on the database. Another good thing in this diagram is that I have created all different components and I have described the roles of each of the component. So that is very nice in this architecture. So these were the good things in my design, but I also received a minor suggestion on this, which was like when I mentioned the fields in the entity URL, I could also include user ID or created by field, like who created this. That will be useful in maintaining the history as per the user, which can be displayed to the user as well on the later stage. So I can have the created by or the user ID field. Apart from that, I could also add creation time field in this entity, and I could add that in this diagram. So that was the feedback that I received. Now you may wonder that I did not include any algorithm or how I will create this short URL. I did not do that because in the question it was mentioned like it is just kind of a starting question for now, and later we would evolve this diagram. So that's why I kept it bit simple in the first go. Now after this, let's move to the fifth question. So the fifth question was like, how will users be redirected from the short URL to the long original URL? So in the last question we talked about how the system will generate a short URL. Now I also have to include like how the short URL will be redirected to the long URL. So let me share my updated diagram for this question. So this is the answer that I gave for this question. You can see I have done bit of the changes in the last diagram. I have added a few components in it so that this question can be solved. Like earlier we have the client, HTTPS is also the same. There is load balancer, there is gateway, there is URL generator service, which we discussed in the last question as well. Then there is database, there is Redis cache. One improvement that I did was like this all is same, but with that I added two fields. One was the creation time and then created by, or you can say user ID. This came as an improvement from the last question. Apart from this, what I did was like I added additional thing, which was the redirectional service. So redirectional service will be used for the redirection part. It would also interact with the Redis cache and the database to have the mapping. So basically in the HTTPS request, I will get the short URL, and from the cache plus database I can get the mapping of the long URL, and then the redirection can happen from that. Additionally, what I did was like add a CDN layer as well. So CDN is generally used for the static assets. I have seen it more to be used like for images, videos, such content, but I just added it here to get the feedback like if this can be used. Reason being, CDNs are located worldwide, so in the different geo locations it is located. So based on the request from the user, the response will be given from the nearest CDN. So whichever CDN is nearest to the user, that will respond back to the user. And the good part here is like when CDN give the response, the request is kind of not even reaching the servers where our microservices are performing the task. So we don't even need to go to the microservice level because CDN would already have that data and they would give that back response to the users. So that would be quite quick and that would reduce a lot of load on the servers. So this was the addition that I made. Now let's see what was the feedback that I received on this diagram. So firstly, talking about the good parts that I received as a feedback, I added a new component, so it's kind of a new microservice, and then I talked about the database and Redis cache. So those are the good things in my architecture. That would be really helpful because kind of like these microservices have separate responsibilities, so it reduced kind of the tight coupling between the system. Another good part is that I have included the Redis cache, and it would be really helpful in the optimizations of the complete system. Okay, so these were the good things, but I also received an improvement point in this design part, which was related to redirection. So in this question, main focus was related to redirection. Although I added a new component, the redirection microservice here, but I did not explain how the redirection will happen. So basically when we use the HTTPS, the redirection can happen with two ways. Number one is status code 301, which is like permanent redirect. So in that case, what happens is like the browser keeps the things in the cache permanently, so every time it gets a match it directly shows that. But in our case, the suggested one is status code 302, which is basically the temporary redirect. So in this case, the redirection is not directly happening from the browser cache. As per the system logic, it would go to the Redis cache. If it doesn't get the mapping from the Redis cache, it will fetch it from the database. So the status code 302, which is the temporary redirect, all those fundamental things I should have covered while explaining this, and I should have also included that in my design diagram. So this was an improvement area that I received from the interviewer. Now why this is important? Because say we followed this 301, in that case what will happen is like browser will keep the mapping in the cache for indefinite period. So the browser would skip all the things, the logics that we have kept in the service. It would never reach to our Redis cache or database. It would always pick it from the browser cache, which is not the correct idea that we want. So we want it to happen using the temporary redirect, which is 302 status code. So these kind of details are important, through which the interviewer would know that you know all such basics and fundamentals, because it is important for this system. Now let's move to the next question. So the next question was like, how do I make sure that the short URL is actually short and is unique? So let me share my answer with you. I updated my diagram for this question. Let me share that. Okay, so this is my updated answer for this question. Few of the things are same: the client, HTTPS, load balancer, gateway, CDN, this URL generator service, database, Redis cache, and this entity part. In the redirection service, I basically added this part like status code 302 redirection, which was a feedback that I received in the last question. So I've added that. So apart from all these, one important thing that I have added is the zookeeper. So the explanation that I gave for this complete design is like, so when we have to create the URL, right, we need to make it short. What are the options to do that? So the first approach could be like, there can be a system which would generate the random UUID, but UUID in general are like big in size. We want the URL to be short, right? So what I thought is like, I could then do the encoding, but even after doing the encoding, the length won't be too small. And also when I'm saying like generating the random UUIDs, there is a possibility that the generated UUID is not unique because I am creating that randomly, right? So there can be collision. So whenever there is collision, I need to check like whether it is already present in the DB or not. So in that way, it won't be that fast. So there is possibility of collision, that is, it might not be unique, and also it might be big. So better approach than this would be to have a system which would simply increase the counter. Say for example, you have the some counter, and then next time a request comes, so the counter would be incremented by 1, right? So there should be one system that would handle it. Now the problem comes is that I can have a microservice for that, but there can be multiple calls at one time. So how do I handle that? And also because it's a distributed system, there can be multiple servers, so the request can go to anyone, so it can become a bit difficult to handle this distributed centralized system. So the approach is good that I would have a counter that would get increased every time, but I need to solve a couple of things. One is related to the centralized distributed thing, and other is about the size. If I am just increasing or doing the increments on that, it can become big. So what I can do is like I can do encoding on top of that. So for encoding, first I need to decide what all characters can be present in the URL, that is the short code that I'm generating, and on top of that how many characters would be sufficient, right? So first deciding what all can be in each of the characters. So I thought of like it can be A to Z in small case, and then A capital to Z capital, and then 0 to n digits. So A to Z in small would be 26. Similarly, A to Z capital would be 26, and 0 to 9 would be 10. So adding all three of these, it would give 62, right? 26 plus 26 is 52, plus 10 gives 62. So now talking about the length, 3.5 trillion combinations, which would be enough, right? So the short code that we want to generate can be of length 7, and the characters could be these, right? So what we can do is like do the encoding with base 62. So in that way the URL generated would be short of length 7, and it is also making sure that it is unique because the counter is incrementing every time. So every time when we increment, it's a unique combination that we are getting. So it solves the problems of short and unique, but how will I resolve the problem of centralized distributed system? So it can be handled by couple of ways. One could be like I could use the Redis cache itself, because Redis is a centralized distributed system, because the increment command in Redis is atomic, which means that it won't get interference from other operations. So that way it is safe to do using Redis. Or as I included the Zookeeper, we could use a centralized distributed system like Zookeeper. The responsibility of Zookeeper would be to give an incremented number each time. So because it's a centralized and distributed system, the problem of, like we said, multiple requests coming and there are multiple servers, that would be handled by Zookeeper itself. So it will give us a incremented number. On top of that, we have the encoding base 62, which would ensure that the URL is short and unique. So this was my answer. Now let's see what was the feedback that I received on my answer. Okay, first talking about the things that I did well in this design. Number one is that these calculations that I made, like the length of this URL and encoding base 62, how that would be 62, that calculations, that was a good thing that I did in my this answer. Apart from that, another good thing was like identifying that we need a distributed centralized system, like we can use Redis or Zookeeper. That's a good understanding that I brought in this answer. Now the minor suggestion that I received on this, of course, the first approach that we discuss about the UUID. The UUID can be really big. It can be 36 characters long, but in case of UUID v4, it even goes till like 128 characters. So this is not a feasible solution using the UUID, and also it could create like issues where it is not unique. There is a possibility of collision, so we can't use this part. One minor suggestion that I received was like I could talk more about the collision strategy. So in case of collisions, like for example we talked about in UUID, how those collisions will be resolved, what would be the strategy to handle that. I think I still discussed this while telling you my answer in this video, but during the interview I didn't mention that completely. So yeah, that was one of the feedbacks that I received. Another feedback that I received was to explain more about the Zookeeper, because generally Zookeeper is not just used for generating or creating the incremented values. It is more likely used for distributed coordination. So when I say like I would use the Zookeeper, I should also know some basic basics or fundamentals related to Zookeeper so that I can explain what is Zookeeper and what it actually does, because that can be asked in an interview. So yeah, basically in the interview, whenever we are using something like when I say Zookeeper, or when I say the short URL would be of length 7, or we would do the encoding of base 62. So there can be basic questions like what is Zookeeper, why are you using this, and why the size of this short URL is 7, why are you using base 62. So whatever you are using in the interview, you should know why you are doing that, because there is high probability that it would be asked as you mentioned it in your solution. Okay, so after this, let's move to the next question. So the next question was, how can we ensure that the redirects are fast? So as you can see, I have kept the same diagram in this. It was like I did not update anything in the diagram here. I just explained and told what are the strategies that would make our redirects fast. So the first thing in my answer is like CDN. The usage of CDN is generally in case of static assets like images, videos, but CDN can be used here as well. How CDN will help is that CDN are distributed across the globe, so it would be present across multiple geolocations. So for example, there is a request from India and say the server is in US, right? So the request has to travel a lot to get back the response, and due to this there would be a huge delay, right? So your redirect would take a lot of time. So now let's say there is a CDN which is present near to India, or maybe you can say it is present in Europe. So this one is near to as compared to US, because the requests are coming from India and the Europe region would be nearer to this request. So what can happen is that this CDN present in Europe can give the response to the request from India. So in that way, this request does not even need to go to the servers and to the database. So in that way, it would be quite fast. So all the requests would be handled by the nearest CDN that would be available, and it would be really helpful because first it would reduce the load on the servers, your system, your database, everything. And another thing is that it is quite fast, so you will get the response in very low latency. So apart from CDN, another thing would be the use of Redis cache. So when we talk in terms of our system, we do not want all of the requests to be served by the database. Why? Because first it would increase a lot of load on the database, and another thing is like when you're serving things from the database, it would take a lot of time, so that won't be fast. In order to make things fast, what we can do is like use something like a Redis cache, which would be key value pair based thing, and it would really help in reducing the load on database as well as increasing the speed of the response. So both of these, CDN and Redis cache, can be used for really fast redirects and low latency. Now let's see what was the feedback that I received on my answer. Okay, in the feedback, first talking about the good things, it was good that I talked about the CDN, the geography, locations, and the example that I told. That can really help in improving the speed, and usage of Redis cache is also very beneficial. So both of these components that I introduced in my design, these are good, and these would work really well in the system. Okay, these were the good things. Now talking about the minor suggestions that I received on my answer. So the first thing was like, because I was talking about the cache, I should also talk about the cache strategy, like which kind of cache strategy am I using? Like, is it least recently used or LFU, or what am I using basically? Because I am specifically talking about the cache and the fast speed, so I should also talk about what kind of strategy do I use in cache, and that would show the interviewer that I know all the fundamentals related to cache. Another feedback that I received was like, because I'm talking about the database and cache here, I should also talk about how would I maintain the consistency between the database and the cache. Like, how do I make sure that these are consistent and the updated data is present in the cache, even in case like when an URL has been expired. So how does the cache also has the correct data as per the database? So both of these things, like the strategy used in the cache and how do I maintain the consistency between database and cache should have also been covered in this, because this question mostly revolves around the cache part. Like for example, when I talk about the consistency between the database and the Redis cache, one thing that can be talked about is the TTL, right, which means the time to live for the values present in the Redis, and it's kind of expiry that is set on the Redis, and based on that there can be other approaches as well, like the event driven mechanisms or the cache aside patterns where the service checks the validity. All such things can be discussed in the interview, so the interviewer can see that you have the understanding of all the fundamentals here. Okay, now let's move to the last question that was asked to me in this mock interview. It was related to scaling, like how can your system scale the support to 10k redirects or the reads per second. So as you can see, I did not make any changes in the diagram. I just explained like what all things can be done here and how does this system handle high load or scale. So here is my answer. So number one is like I'm using load balancer, because when we talk about the distributed system, there would be many servers and we would need the horizontal scaling for that part, and in order to handle the horizontal scaling we would require the load balancer. So I've mentioned load balancer here from the beginning of the design that I created. And then after load balancer there is gateway as well, which would help in authorization, redirection, and another thing which is rate limiting, right? So it would help in a case where a malicious user is trying to put down our server, so the gateway can identify the IP address and block the request. So such things can be handled by the gateway. And then after that, another thing is like this is the microservice kind of model and there is no tight coupling, so each of the service is having its own responsibility. Then I am using the Redis cache here. The cache would be really helpful to reduce the load on the database. A lot of requests can be handled directly by the cache and it would be quite fast. So when there is lesser load on a component, the probability of getting it down is also lower, right? So it would perform better. And apart from that, one more component is the CDN. CDN would really help to reduce the load in overall system. When the response is given by the CDN, your request doesn't even go to the complete system, it doesn't reach the servers or the database, so everything is handled by the CDN itself. So it would really help in scaling the things. Also it would make things very fast. Now apart from all these, when we talk about in terms of database, there can be few things that can be done which would be helpful in terms of handling scale. First would be like replication of the data. So there are multiple strategies how to handle that. Like we create the replicas of the database in order to avoid like single point of failure. So even if one is down, another can take care. We have models like master slave and many others which can handle the replication strategy. Then we can also talk about the partitioning in the database. We can do sharding in the database, and another thing that can be done on the database is the indexing part. So when the query is made to the database, it can made fast using the indexing. So all such things can be done to handle the high load on the system. So this was my answer. Now let's see what was the feedback that I received on this. Okay, starting with the good thing that I did in my design was like first talking about the CDN, it was good, like it would reduce a lot of load. Talking about the Redis cache, that is also great, that would reduce a lot of load on the database. I also talked about the load balancer and gateway. These are the basic components, and these will actually help to handle the high scale. And also the things that I told for the database, like creating replicas or sharding or indexing, those were also good. So this was like the good things that I covered in my design. Now I also received like the minor suggestion on all these. So first one is related to the database strategies that I mentioned, like the replication, sharding, indexing, partitioning. Although I mentioned these terms, but I also should explain all these in, like for example, how would I do that, based on which field? Is it based on the creation date or some hash function on the URL? Like what is the logic of doing all these? Similarly, like when I say indexing, that is fine, but like which field I would would choose for indexing. It can be like the short URL that would be really helpful. So all such thing I should cover, like these are the generic terms that I use, but how are they helping and how are they specific to this system when I'm saying. Another minor suggestion was like when I talk about cache, I should also talk about the cache eviction policy or the cache hit miss ratio kind of things, so that interviewer can know that I know all such fundamentals and we can have discussion on that part, because this question is mostly related to the scale and all these components. Similarly, in terms of cache, I should also talk about the strategy whenever there is a miss, right? So how would that be handled in like high traffic case? Like would that be like read through or something else? So all such kind of things can be discussed rather than just giving the generalized things in the interview. Giving more details about specific to this case, how this would be helpful and on what basis this can be applied, and discussion on that part can be helpful in the interview. All right, so this was the complete mock interview. I hope this was useful to you as well. The basic point of this mock interview is that we can learn from it and we can improve from it, so that we don't repeat the same mistakes in the real interview. And once we do that, the probability of clearing the rounds or getting hired in your dream company increases. So I wish you the best. I hope you crack your dream offers, and if you found this video helpful, press the like button and share it with your friends so that all of us can grow and learn together. All right, then, this is Mohit Chabda signing off. Subscribe to the channel and thanks for watching.